Hello everyone, today we are going to learn about one of the most important pillars of object-oriented programming, which is polymorphism. So it is a concept you have actually already seen in action throughout this series. Today we are just going to give it its proper name and tie everything together. So the word polymorphism comes from Greek. So poly means many, and morphism means behavior or fur. So to put everything together, polymorphism simply means one action behaving differently in different situations. Let me give you a real-life example. Think about a person. The same person can behave completely differently depending on the situation. For example, at school, they are a student, they study and listen to teachers. At home, they are a child, they help with household tasks. At the shop, they are a customer, they buy things and pay. Same person, but completely different behavior depending on the situation. That is exactly what polymorphism means in Java. The same method name, behaving differently in different situations. So Java has two types of polymorphism. Two types. Let's talk first about type number 1, which is called compile time polymorphism. Compile time polymorphism, also known as static polymorphism or early binding. So in compile time polymorphism, Java decides which version of a method to call at compile time before the program even runs. This is achieved through method overloading, which we cover in video 22. So let's have an example. We have a class named calculator. Let me create two methods, access modifier, public, name of, so data type, and name of the method is add two parameter and a and b and curly braces, and we have a return keyword which we want to return for us a plus b, and the second method public and with the same name because it is overloading. So with three different parameters and a and b and c, curly braces, and return a plus b plus c and semicolon. So when we write the main, let me write the main method. When we create the object, let me copy the name of the class to avoid any mistakes. We name the reference variable calc equal new, the name of the class, and semicolon. Now let's run or call each method. The name of the reference variable, dot operator at first 10 and 20. Let's do the same for the second method, calc.add with three parameter 10, 20, and 30. Now let's run the program. Yeah, the answer for the first one is 30 and 60. So for the first method, Java knows at compile time that call two parameters version, and here Java knows at compile time to call the three parameter version. So Java looks at how many parameters you passed and immediately knows at compile time which add method to call. No confusion, no ambiguity, decided before the program runs, depending on the number of the parameters that we add. Now let's go for the second form of polymorphism. type number 2. So in type number 2, which is called runtime polymorphism, which is also known as dynamic polymorphism or late binding. So in runtime polymorphism, Java decides which version of a method to call at runtime while the program is actually running. This is achieved through method overriding, which we covered in video number 41. Let me write it first here. This one was method overloading. The one now that I'm talking about is method overriding. So let's go back to our previous classes that we had in previous videos. Class animal, which was the parent class. Let me create a method here. Public void the name of the method sound. It does not return. And we want to print animal makes a sound, right? Now let's go back to the dog class, which extends animal class, and create same method, public void sound, and call it braces. So you want to write dog barks. Now let's go to the cat class, which is also the child of animal class, and write the same method, void sound, and we want to print cat meows. So now here is where it gets really interesting. For example, I come back to the dog class. I write the main method and I create an object using animal class. Animal 1 is the name of the reference variable, new dog, the name of the class itself, and then I want to call method animal 1 dot sound. Yeah, we can see the result is dog barks. Let's do the same here. Animal, the name of the parent class, and then reference variable name equal new, the name of the class, cat, and semicolon. Animal 2 dot sound. Now let's run the program. Cat mews. Even though both animal 1 and animal 2 are declared as type animal, right? Here and here. At runtime, Java looks at the actual object in here. An actual object, dog or cat, and calls the correct version of sound. Java did not know which sound to call until the program actually ran, because it depends on what object was created. This decision at runtime is exactly what makes it runtime polymorphism. So that is the polymorphism in Java. If you enjoyed this video, make sure to like and subscribe the channel so you never miss a video. See you in the next one.